Hello students, welcome back. So now we are going to talk about the design of 4x1 multiplexer. So in this video, we are going to talk about the working principle of a 4x1 multiplexer, what can be the problem in the design process, and then finally how do we design it using the module instantiation technique. So let us get started. So 4x1 multiplexer, the basic idea is same. There are going to be 4 inputs, and for those 4 inputs we need 2 select lines, and y is our output variable. So this is the block diagram. I0, 1, 2, 3, 4 input variables, S1, S0, these are 2 select line, and y is the output. So now we make the truth table, and the first thing that we realize that effectively we have 6 inputs. That means there are going to be 64 cases in my truth table, and it is not possible to solve this truth table. So we are stuck. So the conventional method is not going to work. Then what should we do? Then we think about the logical operation. We understand that y is equal to one of the inputs based on the combination of select line. If it is 0, 0, y is I0. For 0, 1 it is I1. For 1, 0 it is I2. And for 1, 1 it is I3. So from this we make the Boolean expression. That means S1 bar, S0 bar and I0, this is my one case, and that is how I make all the 4 product terms and I take their sum. So 0, 0 with I0, 0, 1 means S1 is with bar and S0 is without bar, so that means 0, 1. For I2 it is 1, 0, that means S1 will be normal and S0 will have bar, and for I3 it is 1, 1, that means S1 and S0. So now I have this expression. You can go to data flow modeling and simply implement this, it will work. But what we are going to do, we are going to implement it using module instantiation. So here is our Boolean expression. If we take S1 bar common in the first two terms, then we find that S0 bar I0 plus S0 I1, and similarly if we take S1 common in the last two terms, then we have inside the bracket S0 bar I2 plus S0 I3. These highlighted terms, they are actually a 2x1 multiplexer. In the first one, S0 is the select line and I0 and I1 are the inputs. In the second one, S0 is the select line and I2 and I3 are the inputs. And if I assume these two as P and Q, then I get another 2x1 multiplexer, which is the last line and which says S1 is the select line and P and Q are the input. So we can implement a 4x1 multiplexer using 3 2x1 multiplexers. So now we get a good idea that we are going to use module instantiation. So let us test it using Vivado now. I am creating a source inside the same project. Do not change the project every time, that we have already informed. So here we are going to have 4 inputs, I0, 1, 2, 3, 2 inputs S1, S0 and 1 output variable. So here we have the module declaration. We need the wires P and Q as well, and then we start the module instantiation. You can take any multiplexer that you want from 2x1. So I take MUX underscore 2x1 underscore gate, and this is the instantiation. The order of the variable is important. For the first one, the order was I0, I1, S and Y. So I0 is going to I0, I1 is going to I1, S is S0 and the output is P. Then we can just copy this and paste 2 more times, and here we say this is D1, this is D2, For the second MUX, inputs are I2 and I3, select line is S0 and output is Q. For the last MUX, the inputs are P, Q, select line is S1 and the output is Y. So that is all we have. We save it and we'll see what is the schematic. So here in the schematic we can clearly see that S0 is the select line for these two multiplexers and S1 is the select line here. I0, I1 are here, I2, I3 are here, and these are P and Q which are going, and we are having the final output Y. So students, now we have implemented 4x1 multiplexer also. There is a special feature that multiplexer has, and that is that we can implement any function using a multiplexer. How can we do that? We are going to talk about that in our next video. Keep learning. Thank you.